Harshavardhan, unmute yourself and tell me the screen is visible and audible. Shahid, unmute yourself and tell me the screen is visible and audible. Harshavardhan. Jishan.
Sir, screen is not visible, sir.
Okay. Now?
Visible, sir.
Okay. Good morning, everybody. Today, I start the new module, Solidification and non-ferrous foundry practice. All of you, please write down Module 3, Introduction to Solidification. All of you, please write down Module 3, Introduction to Solidification. So what do you understand the word solidification? What is the meaning of that word solidification? Say, you are all belongs to mechanical engineering. The solidification means the transformation from liquid phase to solid phase. Liquid phase to solid phase. How do you convert solid phase to liquid phase? That is nothing but use furnace or oven or any method. From that it will convert, transform solid into liquid. Keep the liquid in the open air or in the some controlled environment. You can change or you can transform solid liquid into solid. Liquid into solid. That is phase transformation. How the phase transformation takes place in metal. That's very, very important. How the phase transformation takes place in metals. Usually, we observe different types of solidification process that we study later classes. Today, you just understand what is solidification. Solidification is nothing but the transformation from liquid phase to solid phase. So what are the changes you observe? What are the conditions which promote the solidification? That's very, very important. The in introduction of solidification, that is nothing but transformation of phase, PHASE, phase from liquid phase to solid phase. If you allow the liquid metal to dry, change its phase from liquid phase to solid phase. Let's come to the point. That is a very, very important. The freezing point and the melting point. So what is the difference between freezing point and tell me?
Sir, ಅಲ್ಲಿ ಸ್ಟೂಡೆಂಟ್ಸ್ ವೇಟ್ ಮಾಡ್ತಿದ್ದಾರೆ ಸರ್ ಲೆಟ್ ಇನ್ ಮಾಡ್ಕೊಂಡು.
ಇದ್ರಲ್ಲಿ ಯಾರು ಕಾಣಿಸ್ತಾ ಇಲ್ಲಲ್ಲ? Those who are came late, write down the new module, module 3, Introduction to Solidification. Introduction to Solidification. So what is the meaning of solidification? The solidification is nothing but changing the phase of the metal, changing the phase of the metal. If you provide the heat to the metal in the furnace or in the oven or by other means, convert the metal into liquid phase. Pour the liquid metal into the mold cavity. Leave it for 2 minutes or 3 minutes, depending upon size, shape, and type of metal. All of a sudden, or in a few moments, from 20 seconds to 20 minutes, the solidification takes place. What actually happens in the solidification? In the solidification, the change, the transformation of liquid phase to solid phase takes place. That is nothing but the liquid metal changes into solid metal. Liquid metal changes into solid metal. That is called solidification. That is called solidification. One thing, you can see the water and you can see the ice. The water is in liquid condition, ice is in solid condition. So if you leave the ice in the open air, what will happen? It becomes liquid. So that's the different process. But in metal, it is direction. That is nothing but if you give the heat to the metal in the oven or in the furnace or in the induction furnace, the metal changes its phase from solid to liquid. Then you pour the liquid metal into the mold cavity. The transformation of liquid phase to solid phase takes place from 20 seconds to 20 minutes of time. So that is the solidification process. Next, come to the point. The freezing point, melting point, the difference between freezing point and the melting point. See, the freezing point means the freezing. What is the meaning of freezer? That is, that extract the heat and forms the solid. Extract the heat and forms the heat, solid. That is the freezing point. That is, all of you go through this. All of you please write down Introduction to Solidification. Introduction to Solidification. In Foundry, write down, please all of you write down Introduction to Solidification. Underline that. Underline that. In Foundry, the solidification defined as the process by which instead of writing substance you write down metal. Solidification is the process by which the metal undergoes phase transformation from liquid state to solid state. Liquid state. In bracket write down liquid phase to, phase means F, don't write FSE, write down HASE. Liquid phase to solid phase. Liquid phase to solid phase. Next line write down, next paragraph. In a casting process, put a comma, as the as the molten or liquid metal is poured into the mold cavity comma, it begins to cool. It begins to cool. When the temperature falls or drops, when the temperature drops below the freezing point or melting point, of the metal, put a comma, then solidification starts. Solidification starts. Solidification starts. Next paragraph right there. Further, during solidification, put a comma, the atoms or molecules in the metal are rearranged leading to change in microstructure results in changes in the properties of the metal. Change in the microstructure results in changes in the properties of the metal, such as strength, toughness, malleability, ductility, etc. By controlling solidification process, by controlling the solidifications, solidification process, comma, controlling the solidification process, comma, the microstructure can be altered. And hence the properties of the metal can also be altered. Can also be altered as as required. As required. Suppose if I have question in the examination, define solidification, you write this much. It is the transformation of a liquid phase to solid phase, or change or change from liquid state to solid state. And you can change the microstructure of the metal or metal by controlling the solidification process. How do you control? By controlled environment or controlled situation, you can alter the microstructure of the metal. Then you can provide many properties such as ductility, malleability, toughness, and other mechanical properties by controlling the solidification, which alters the properties of the metal. So this much you write in the exam. Next, come to the point, freezing point. That is, say, the melting temperature of cast iron is 1350 degrees centigrade. The melting temperature of aluminum alloy is 600 degrees centigrade. If the melting temperature below the 600 of aluminum or 1350 of cast iron, that is called freezing point. Cools below the its freezing point, that is nothing but melting point of the metal. Below the freezing point means, or melting point means, freezing point. For example, if it is non-ferrous aluminum, the temperature falls below the melting point means below the 600 degrees centigrade. If it is cast iron, below the 3350 degrees centigrade, that is called freezing point. Remember, in your lifetime, melting point or freezing point means, that is the temperature at which metal starts solidification. Metal starts solidification process. That is, liquid metal starts to solidify, starts to solidification. That is nothing but starts to solidify. That is called the freezing point or melting point of a particular metal, whether ferrous or non-ferrous. Liquid metal falls below the melting point or freezing point means the process of solidification starts at that point, or at that point the liquid metal starts to solidify. So the atoms begins to grow in size. First nucleus appear, which attract the neighbor nucleus and form the nuclei. See, all of you observe here in the first diagram, this is the nucleus. See, all of you observe here, this is the liquid metal or liquid metal. This is the, see here, number one, number two, number three, forms the nuclei and attract the neighbor nuclei and grow in size. Grow in size. Grow in size. For this good example, say if power goes, you lighten the candle. The droplets fall from the flame on the candle. If you touch with bare fingers, what will happen? Some portion of wax is stick to your finger. That is nothing but the solidification process. Liquid wax turns to solid when the heat extracted from the material, that is from the finger, the heat is extracted from the liquid, so the liquid changes into solid. This is good example. If the light goes, you light the candle. If you touch the liquid wax, that becomes solid. That is nothing but heat extracted from the liquid wax, then it starts to form solid. That is good example. In the same way, in the metal, the formation of a structure takes place due to solidification. All of you observe here. This is the process carried out in the liquid metal. Nuclei appear in the liquid metal and grow in size and attract the neighbor nuclei and forms the structure. Forms the structure. All of you observe here. The first nuclei appears, attract the neighbor nuclei or grow in size and forms the crystal growth or forms the crystal. The nuclei grow in size, forms the crystal. See one thing, what is the age of a human being? The growing age, or that is the growing age is 19 years. After that, the growth ceases. Growth ceases. The growth will come to the standstill condition. The same way, the nuclei grow in size and attract the neighbor nuclei, forms the crystal. This process is called nucleation. Nucleation. This process is called nucleation. And afterwards, all of you observe here, see here, three nuclei are present and which makes the crystal like this. Come to the second diagram. That crystal grow in size, reaches the maximum. That is nothing but critical size of the nuclei. Critical size of the nuclei or nucleus. As I told you, the growing age of the human being is 19 years. Afterward, growth ceases. Same way, in the metal also, grow in maximum size, that is the critical size of the nuclei. At that size, growth ceases and forms the crystal and grow in size, that is attract the neighbor nuclei and forms the structure. Forms the structure. All of you observe here, this is the grain boundary, that is the maximum size of the nuclei. The grain boundary forms and that is the maximum size of the nuclei. That is first, all of you observe here, write down the rough diagram of nucleation, crystal growth and grain boundary. In solidification, three words are very, very important: nucleation, crystal growth and grain boundary. In later we study how the crystal growth takes place in metal. All of you please write down three diagrams. Write down first three nuclei like this and the structure looks like a star. Write down, this is liquid melt and nuclei grow in size, attract the neighbor nuclei and forms the structure crystal like this. Looks like a star with four arms. With four arms. And this is the crystal or grain. See, all of you observe here. Looks like a structured crystal. Structured crystal that grow in size and forms the grain boundary. Grain boundary. Please, all of you write down, when a liquid cools below its freezing point, below its freezing point or melting point, below its freezing point or melting point, comma, it starts to solidify. It starts to solidify, and the atoms of the liquid metal, atoms of the liquid metal begin to bond together, forming a very small, sized crystal, small sized crystal called nuclei. See, crystal called nuclei. This process takes place at several points, or locations, takes place at several points or locations in mold cavity. See, all of you observe here. What is the condition for solidification? That is heat extraction. Remember, in your lifetime, the heat extraction, that is the heat transfer between the bottom of the mold box, heat extraction of the mold walls, heat transfer between the mold walls. Next, heat transfer between the surface to the surrounding. Say, in three steps, in three directions, the solidification takes place. That is the heat transfer between the liquid metal and the bottom of the mold box, heat transfer between the liquid metal and the mold walls, heat transfer between the liquid metal and the mold walls, heat transfer between the surface of the liquid metal and the surrounding. See, in three directions, nuclei forms, grow in size, attract the neighbor nuclei, and forms the crystal. Again, formation of crystal, then the crystal grow in size, reaches the maximum size, that is called critical size of the nuclei. That is critical size of the nuclei. Crystal grow in size and reaches the maximum, that is called crystal growth, and reaches the maximum, that is called critical size of the nuclei. See, three words are very, very important in solidification. Number one, nucleation. Number two, crystal growth. Number three, grain boundary. All of you please write down three diagram. One is nucleation, second one crystal growth, third one grain boundary. Next, come to the point of very, very important. Write down dendritic growth of crystal, colon, equiaxid dendritic growth. Equiaxid dendritic growth. If possible, write this diagram in the examination. Say, all of you observe here, which looks like antenna. Say, 15 years or 20 years back, we don't have any connection for TV. Nowadays, that is from satellite direct to our home, DTH and cable connections. From that we receive the signals, and from that we watch the TV channels. But 20 years or 25 years back, only the Doordarshan is available. For that, we have to install the antenna in our rooftop of our house. There, we receive the signal from the transmission tower of TV, LPT or HPT, high power transmission tower, or low power transmission tower, which is situated in Vidyanagar, Shimoga. From that, we receive the signals, and we have to install the antenna in our rooftop. From that, we get the signals, and from that, we watch the TV of Doordarshan. But nowadays, you have DTH, direct to home, and cable, and from that, we receive the signal. The antenna, all of you seen the conventional method of antenna, conventional method of using antenna. The same type of structure formed in two directions. All of you observe here, X and Y, X and Y. The crystal grow in size. All of you observe here in the first diagram. See, that is grow in four directions, in four arms. In the same way, this is the solid, the interface between the grain boundary and the crystal. That is, the crystal grow in size, attract the neighbor nuclei, and forms the nuclei. This is the critical angle of the nuclei alpha. Grow in size, that is direction X, grow in Y direction, and this is the center O, attract the neighbor nuclei and grow in size. This is the diagram for dendritic growth of the crystal. Dendritic growth of crystal. Equiaxid dendritic growth. All of you observe. Equiaxid. Equi means the same dimension, length in two directions, X and Y. Equiaxid dendritic growth. Remember, dendrite. Dendrite means antenna. See, all of you belongs to mechanical engineering. Dendritic growth means antenna structure. Antenna structure. This is the actual metal of aluminum, which is observed through the scanning microscope. From that, how the dendritic growth takes place in 1 millimeter distance. All of you observe here. This is very, very important and interesting one. How the dendritic growth takes place. This is the actual aluminum liquid solidification process. Aluminum solidification process, and how the growth takes place in the mold cavity. See, observe here. This is 1 millimeter length. How the growth takes place in the liquid metal. That is, the nuclei attract the neighbor nuclei and forms the crystal. This photograph taken from scanning electron microscope, SEM. All of you write down. Write down, if possible, write down this diagram. And these two are the dendritic growth of iron, dendritic growth of aluminum. This is the actual diagram taken from scanning electron microscope. Scanning electron microscope. In the controlled atmosphere, the phase transformation of liquid aluminum and liquid iron. See how the growth of the crystal takes place in liquid. All of you observe here. These are the actual photographs using SEM, scanning electron microscope. These two photographs indicates the growth of the crystal. Dendritic growth. Dendritic growth. That is the crop. That is the how the crystal formed in the liquid metal. Say, all of you observe here. The crystal grow in size in two directions. That is X and that is Y. And this is the angle. That is the critical size of the nuclei. This is the critical angle in which angle the crystal grow in size. That is, attracts the neighbor nuclei and grow in size, and the angle is alpha. All of you observe here. Please write down dendritic growth of crystal colon equiaxid dendritic growth. Equiaxid dendritic growth. This is very, very important. All of you understand what is dendritic growth. When you heard the word dendritic growth means antenna structure. Antenna structure. So in the conventional method of receiving signal from, that is through antenna, the low power transmission, high power transmission towers of TV, they transmit the signals. That antenna receives the signal. In TV, we have the receiver, and which receives the signal, converts that into picture or image. That in the same way, the crystal grow in size. What is the mechanism behind the growth of the crystal? That is nothing but the crystal grow in size in two directions. That is X and Y. In X, all of you observe here in which angle the crystal grow in size. That is the critical angle of the crystal. In that direction, the crystal grow in size. That is, the nuclei attract the neighbor nuclei, that due to the heat transfer between the liquid metal and the bottom of the mold box, heat transfer between the liquid metal and the mold walls, heat transfer between the surface of the liquid and the surrounding. In three mechanism, the solidification process starts. First, the nuclei appear in the liquid metal and grow in size and forms the crystal. How the crystal forms? This nuclei attack the neighbor nuclei and forms the crystal. And crystal in grow in size reaches the maximum, that is called critical size of the nuclei. And then you can observe the boundary. Then you observe the boundary, that is called time boundary. Three words are very, very important in solidification. First word, nucleation. Second word, crystal growth. And third one, grain boundary. This is the actual photograph taken from the solidification process of aluminum and iron. Please, all of you write down the dendritic growth of the crystal, dendritic growth of the crystal, colon, equiaxid dendritic growth, equiaxid dendritic growth. Write down this diagram and show the x-axis and y-axis and the center O, and show the slope line, show the angle alpha, critical angle, critical angle. So these two nuclei. Below that, write down. Below that, write down the solidification process. Solidification process starts in three locations. Solidification process starts in three locations. They are below that, write down number one. Below that, write down number one. Next line. The heat transfer between the liquid metal and the bottom of the mold cavity. Bottom of the mold cavity. Next line, write down number two. Next line, write down number two. The heat transfer between liquid metal and the mold walls. Heat transfer between the liquid metal and the mold walls. Next line, write down number three. Next line, write down number three. The heat transfer between liquid metal, surface of the liquid metal, and the surroundings. See, if you go to any industry, for example, SW in Ballari or Bangalore, 100% guarantee they ask you the question on solidification of aluminum and steel, aluminum and iron. See, for that reason, all of you understand the solidification is very, very important for mechanical engineers. The solidification process starts with the three word, that is first word, nucleation, second, crystal growth, and third one, grain boundary. And this is the process the word dendrite or dendritic growth. Once you heard the word dendrite or dendritic growth, you must have the antenna structure in your mind. Antenna structure in your mind. So this is the growth of the crystal. That is nothing but attract the neighbor nuclei, forms the crystal grow in size and reaches the maximum. That's called critical size of the nuclei. And in which angle the crystal grow, that is the angle. All of you observe here, this is the slope and this is the critical angle of the nuclei, that is alpha. These two are the actual photograph of aluminum and the iron. Aluminum and the iron taken from the SEM, that is scanning electron microscope. So this is the explanation for the crystal growth. Crystal growth. So this is the explanation for crystal growth. So as per the diagram A, B, and C, the explanation for nucleation, crystal growth, and these are the three diagrams. One is actual diagram, and these two are the scanning electron microscope. Photograph taken from scanning electron microscope, SEM. Now I stop at this stage. Please, all of you, write your name and USN in the chat box and answer all call. All of you unmute yourself. Answer or call. Manoj YB.
Yes, sir.
Jishan Ahmad.
Yes, sir.
Prathamesh.
Present, sir.
Sushant.
Yes, sir.
Shahid.
Present, sir.
Nazma.
Yes, sir.
Kumaraswamy.
Present, sir.
Vivekanand.
Present, sir.
Adil.
Present, sir.
Hemant.
Yes, sir.
Sahana. Manoj H. And then RC.
Yes, sir.
Abhiram.
Yes, sir.
Akshay M. Anush. Satish.
Present, sir.
Hemant Nuchin.
Present, sir.
Nayaz Sharif.
Yes, sir.
Lohit Kumar.
Yes, sir.
Nikhil Gowda.
Yes, sir.
Harsha MR.
Present, sir.
Ketan. Danish Bhatt.
Present, sir.
Sharat Narik. Kritik.
Yes, sir.
Abhilash. Aditya.
Yes, sir.
Harshavardhan.
Present, sir.
Jnanesh.
Yes, sir.
Darshan SS.
Present, sir.
Daud Rasul.
Present, sir.
Darshan SS.
Yes, sir. Yes, sir. Present.
Kumar Swami. Karthik R.
Yes, sir.
Madhusudan.
Present, sir.
Saeed.
Yes, sir.
Pratik S. Dhanush.
Yes, sir.
Aditya J.
Yes, sir.
Yes, sir.
Aditya J.
Yes, sir. Yes, sir.
Anybody else? Please tell me your name.
Kumar
Manoj
Swami, sir.
Manoj S. Okay. Next.
Kumar Swami,
Yes,
sir.
Kumar
Sir,
Swami.
Nishchit Gowda.
Okay. Nishchit Gowda. Okay. Chaitan. Okay. Next.
Aditya.
Aditya. Okay, ma. Okay. Now I stop at this stage. I'll continue in the next class.